Okay, so you've granted them energy so that when you collide them, you break them apart. You're basically deconstructing nature to see what residue comes out of it. When I think of doing that for anything else, it's going to break, right? I don't take chairs and slam them together and still have chairs. I have a pile of kindling, okay? So who ever thought it was a good idea to smash nature into itself?
Well, I suppose Ernest Rutherford initially. So we go back to Manchester, the turn of the 20th century, and Rutherford was using radioactive decay to essentially produce the particles. I mean, it's just the decay of atomic nuclei that naturally happens to produce high energy particles, which he then fired into gold foil and bounced them off the foil. In doing that, he discovered the atomic nucleus. So one way to think about particle physics is that when you collide things together, what are you doing? You're really building a microscope. One way to think of it is that the higher the energy of the collision, the faster these things are traveling, the smaller the object you can see. So we were talking about seeing for the first time in those experiments the atomic nucleus. You move forward to ultimately through the 50s and 60s, and we have higher and higher energy collisions. You start seeing that the nucleus is made of protons and neutrons, and then you start seeing it in the 50s and 60s that the protons and neutrons are made of smaller things called quarks, and so we discover those. We've not discovered anything smaller than that, by the way.
Is it because you don't have enough energy to bust up a quark?
Yes, or to resolve what's inside it, let's say, to build a microscope.
Because right now, the inventory of fundamental particles includes quarks.
Yeah.
So somebody saying that's fundamental, which sounds a little like the Greeks saying atoms are fundamental.
Oh no, well, they won't be fundamental. You're absolutely right, but they look point-like from the point of view from the energies that we can generate today. But that's one side of particle physics. So we've been exploring the structure of matter, which is historically, it goes back to Rutherford, I suppose.
And again, you have confidence that when you break matter apart, you didn't break the matter. You're just deconstructing it.
Yeah, it really, I think the way to think about it, you think about what a collision is. So let's say you collide, as we did in my PhD, electrons and protons together. So you get an electron beam and a proton beam, and you smash them into each other. What's actually happening is one way that the collision can happen is that the electron can emit a photon, which is a particle of light. And the particle of light goes and it hits the proton. Now, the wavelength of that light, which is telling you how small a thing you can see, is proportional to the energy of the thing. That's how hard we're smashing things together. So the faster you smash them together, the faster you smash together, the higher the energy, the smaller the wavelength. So the smaller the things that you can see.